All right, writing linear equations. Let's go. So earlier, you've been able to write an equation with slope and a y-intercept, given an equation, a table, or 2 points on the graph of a line. So now in this lesson, we're going to do the opposite. They're going to give you, so we're now going to write the equation. So there are a lot of different methods for writing a linear equation. If you know the slope and y-intercept, you can then write it as an equation of a line by substituting the values in y equals mx plus b. So the slope of an equation in slope-intercept form, write this. So they're going to give you the slope and the y-intercept. So we simply take our slope-intercept form. We then replace m with 1/4 and b with 7, so 1/4 and 7. And that's it. Oh, that was the question. Thought we were doing more with that. And check, you're done. Write an equation for a slope-intercept form for this line, a slope of 0 and a y-intercept of -3. So we take our slope-intercept form again. We replace m with 0 and b with -3. Well, something's going to happen to that 0 there and m. So once we simplify that, or the 0, these cancel, and that gives us y equals -3. So write an equation in slope-intercept form for this line, 2 and a y-intercept of 0. Uh-oh, another 0 problem. So y equals mx plus b. Put in my slope, put in my b, or my y-intercept, and then we have to simplify that to y equals 2x. All right, your turn. Write an equation in slope-intercept form for each line. Go. All right, so I'm just going to write my big one up here. Y equals mx plus b. So I have my formula. So y equals slope of -3 plus -5. So then that would simplify to y equals -3x minus 5. So that would technically be like that. So that should be the first one. All right, now we got to deal with the zeros here. So y equals 0x plus 9, and that'll go to y equals just 9. After we cancel that one out, y equals slope of 4x plus 0 will then simplify to y equals 4x. All right, write an equation in slope-intercept form for the line graphed. So we're going to look at the line, and we have to make a slope-intercept form. So we can, if I read the graph here, I can look in the middle and say that the y-intercept is at 0, -4. And then I just kind of can count up and, here's rise, run, rise, run, rise, run. So it looks like I'm going up 1 over 1. And I'd probably even write that rise over run, rise of 1, run of 1 equals 1. So I take my slope-intercept form. I replace my slope with 1, which is what we figured out, and my y-intercept with -4. Now I got the -4 again. I just counted 1, 2, 3, 4 down, and there's my y-intercept by reading the graph. I simplify it out with the 1 there and the negative, so y equals x minus 4. All right, read the graph, come up with the slope-intercept, go. All right, so my y-intercept is 1, 2, 3. Y-intercept equals 3. And my rise over run. Yes, this is how you show your work, by the way. So my rise is going to be, let's go 1, 2, and then 1, 2, 3, 4, 5. So 2 over 5 would be my run, m. Or you could go m equals rise over run. So I'm going to put those in. Y equals slope of 2/5 plus 3. Oh, forgot one thing though, positive or negative. It is going in a downward angle at the end, so this would be a negative. So I missed one little detail there. It's always the negative symbols with me. All right, the owners of Good Times Eatery surveyed their customers to find out where they lived. They learned for each 0.5-mile radius from their restaurant, 30 fewer people visited them. They had 150 patients in the area immediately surrounding the diner. Write an equation to show the relationship between miles and customers. All right, so the number of customers decreased by 30 for each 5-mile radius. So we're going to say X is going to be miles and Y is going to be customers. So X is going to be miles and this is going to be customers when we graph it. Just kind of get what two things are involved in this. So we're going to find our equation. So we need to find change in Y, and Y equals mx plus b. So to find our slope, we're going to say it decreases 30 customers for every increase in 5 miles. So that would be negative 30 over 5, because that's what we chose as our, X was down here, Y was here. So we can come out to negative 6 would be my slope. And then to find the y-intercept, well, X and Y, the distance to customers. So 0 distance would be B customers. So when the distance is 0, the customers numbered is 150, which they already told us. So you kind of got that one out of just what they told us at the very beginning here, where they said they had 150 patrons in the area immediately surrounding. So that's where we get our starting position, or where, the closest area in this case. So my starting position is going to be that. So then I write my equation. There's 150. So I have my slope and my y-intercept, which gives me a equation of y equals negative 6x plus 150. All right, so predict the way the customers who lived 20 miles away. So we'll take that equation that we just got, and we're going to replace x with 20. And once we simplified that, multiply by 60 and subtract it from 150, it would come out to 30. So at a distance of 20 miles, the number of customers is 30. All right, your turn, go. All right, outdoor sporting event is affected by the temperature outside. When it's at 0 degrees Fahrenheit, the attendance is 12 people. Not a lot of people. For every increase of temperature of 20 degrees, the amount increases by 100. So write an equation to show the relationship between temperature and attendance. Oh good, they even told me X and Y. All right, so at 0, we'd have 12. So that looks like a y-intercept. So y-intercept is going to be 12. So as it increases by 20, it decreases by, so they said temperature is going to be X, so temperature is 20. And it increases by increase of 20 and an increase of 100 to give me my X over Y. So that would be temperature over attendance. So that would give me, when I reduce that down, that'll go to 2 over 10. 1 over 5 would be my slope. So I can make a y equals 1/5 x plus 12. So predict the temperature at 150, or at 60 degrees, y equals 1/5 and 60 plus 12. 60 divided by 5. Because that'll go to over 5. 60 divided by 5 is 10, 12. 12 plus 12. So 24? That doesn't seem right. Let's see if I got my stuff here. 5. Oh, I flipped them. So temperature X, temperature of 20 degrees. For every 20 degrees, it increases by 100 people. Oh, y over x would be rise over run. So I did that backwards. So this should have been rise over run would have been 5 over 1. So that would have made this 5, which would have made this 5, which would make that 30 plus 12. Plus 12 would make that 42. Wait a minute. 5 times 60. I'm just not having a good day here. 300 and then 12. Maybe I should actually use the calculator. Might help me once in a while. No big deal. All right, write an equation for the line that passes through 7, 0, and 6, 3. So we first have to find the slope. Well, we're going to use our slope formula for that. So I take y2 minus y1, x2 minus x1. I define which one's going to be x1, y1, x2, y2. Punch them into the equation. Comes out to -3. Find the y-intercept. Use the slope and the coordinates of either point. So I take slope-intercept form. I put in 1 point, which is 0, 7. That's even easier because that gives me the 0. And so 0 would be, or with that being 0, my intercept is going to be 21. So I can then I can substitute the slope and y-intercept in, -3x plus 21, and that would be my answer. All right, your turn, go. All right, so I'm just going to label them over here. Let's call this one x1, y1. Let's go x2, y2. So I'd have -14 minus 2, minus a -2, and a -2 minus 4. So that would go +2, so that's going to go to -12. Over a positive, or over a -6, which will make that a +2. Will be my slope. I need to find my y-intercept. So I go y equals mx plus b. And so here's my slope of 2. And I'll pick one of these points. Let's do this one. So x is going to be 4. Y is going to be -2. Hopefully I picked the right one here. So that'll be 8 plus b -2. So we'll subtract 8 gives me -10 equals b. So then I'd have y equals 2x minus 10. Hey, I like it when it works. Oh man, I need to keep moving here. So use the table values to write a slope, or write an equation in slope-intercept form. So we're going to use the slope m by coordinates of any of these 2 points. So we're going to use our slope formula. We're going to designate x2, x1, and x2 for equations, and it looks like they just picked the first 2, which works just fine. And that comes, once I punch those in, that gives me -6. We're going to use those to find my y-intercept. So we take one of the points, and the y and the m slope, doesn't matter which point, any point should do. After we simplify out, we get a plus b. So slope-intercept form would be -6 plus 4. So y equals -6x plus 4. All right, our turn, go. All right, so I'm going to go y2 is 2 minus y1 is 4. x2 is -3 minus a -6. So that goes to 6 over -3 plus 6 is going to be 3. So that's going to come out to 2. Is it positive? Positive? Positive. Yep, +2. So I then take y equals 2x plus b. I'm going to pick that point. Why not? 6 and -4 plus b. Wow, this thing is on the fritz today. 12 equals -4 plus b. Subtract 12 gives me -16 equals b. So I'd have y equals 2, got the slope, x minus 16. Wait. All right, we get to play a game of Where Did Mr. Evans Go Wrong? 2 minus 4 is -2. would give me a slope of negative 2 over 3. So then we'd have negative 2 over 3 here. And once we put the numbers in and multiplied it out here, negative 2 over 3, that would come out to 4. So that would be a positive 4 would then be here. We'd add 4, would give me a 0 for B. So that's how then it ends up being y equals 2, 3, negative 2/3 x.